Woodpeckers spend their days slamming their heads into trees, yet they somehow walk away without brain injuries. That remarkable resilience has caught the attention of scientists, who decided to borrow a few tricks from nature to solve a very human-made problem. The result? A fixed-wing drone that can handle collisions far better than anything you've seen before. Now, fixed-wing drones are loved for their speed and efficiency compared to multi-rotor types, but they come with a serious downside. If they crash into something solid, like a tree, the damage is often catastrophic. Multi-rotor drones can wear protective cages, but fixed-wing designs don't exactly leave room for that kind of add-on. What engineers needed was a way to let the drone take a hit without destroying itself. That's where researchers at EPFL in Switzerland stepped in with their SWIFT drone. SWIFT, short for Shockproof Woodpecker-Inspired Flying Tensegrity, uses a clever design based on a structural principle called tensegrity. If you're not familiar, tensegrities are self-stabilizing frameworks made of stiff parts held together by cables under tension. The idea is both lightweight and incredibly tough, making it the perfect fit for drones that need to survive rough impacts. To understand how the SWIFT drone works, it helps to look at how woodpeckers manage the same trick. Their skulls are specially designed with a hard beak, a flexible hyoid bone that wraps around the skull, and a layer of spongy bone that cushions impacts. Add in some extra space around the brain, and you've got a natural system that channels energy away from the brain instead of letting it take the full force of the blow. The SWIFT team recreated that setup with modern materials. Carbon fiber rods play the role of the beak, while bent strips of carbon fiber mimic the flexible hyoid. Elastic cables stand in for the spongy bone, and carbon fiber plates connected by lightweight plastic brackets form the skull inside, where a woodpecker would keep its brain. The drone houses its electronics, motor, and propeller. These delicate parts are suspended with rubber cables, allowing them to shift by as much as 22 centimeters during a crash, just enough to absorb the energy without breaking. The innovation doesn't stop at the drone's body. Birds also use soft tissues in their shoulder joints to help absorb the shock of their wings hitting obstacles. Engineers replicated that in the SWIFT drone using a web of 12 elastic cables and carbon fiber rods, connecting each wing to the fuselage. This setup not only prevents the wings from snapping off during collisions, but also reduces the strain that could otherwise harm the drone's vital electronics. When all of this comes together, the result is pretty impressive. The tensegrity-based systems built into the SWIFT drone cut impact forces by as much as 70% compared to a regular drone of similar size. That means fewer broken parts, fewer crashes ending in total loss, and a much tougher flying machine overall. In short, scientists took a page out of the woodpecker's playbook and gave fixed-wing drones a fighting chance against the hazards of the real world. By combining natural inspiration with smart engineering, they've created a flying robot that can crash and keep on going.